Hello everyone, this is Mohammad Asad Amin, lecturer in physics, Education and Literacy Department. Regarding SIN College Lectures YouTube channel, I would like to deliver you a lecture on magnifying glass or simple microscope from chapter number 10. I hope you will find this lecture interesting and informative. Introduction. Whenever any object AB is placed at a distance D, which is least distance of distant vision from an eye, it subtends an angle directly on an eye called visual angle and is denoted as alpha as shown in the diagram. The apparent size of an object depends upon its visual angle subtended on the eye. The greater is the visual angle, the larger is the apparent size of the object. Now in the diagram, D is the least distance of distant vision, which is 25 cm or 250 mm for a normal human eye. A convex lens of short focal length is used to see the details of an object when an object is placed within its focal length. Such a lens is called magnifying glass or simple microscope. Magnifying power or angular magnification. Magnifying power or angular magnification of magnifying glass is the ratio of visual angle subtended by the image seen through a magnifying glass to visual angle subtended by the object when placed at the least distance of distant vision when seen through the naked eye. The magnifying power is denoted or represented by an equation beta upon alpha, which would be our equation A. In the diagram, AB is an object which is placed at a distance D, which is least distance of distant vision, and it subtends an angle directly on an eye called visual angle and is denoted as alpha in the diagram. Now these visual angles are very small, therefore we can take alpha is equals to tangent alpha and beta equals to tangent beta. Now here I am not talking about the angle beta, rather we have denoted our angle here in the diagram as an alpha. So if you consider right angle triangle ABE, so tangent alpha is equals to perpendicular upon base, which is AB upon EB. Since tangent alpha is equals to alpha, therefore alpha becomes equals to AB upon D, which is our equation A. Now in the diagram we have kept a lens in front of an object, and now when it is seen through a lens, it subtends an angle beta to our eye. Now if we consider right angle triangle OPE, tangent beta is equals to OP upon PE, and as you know that tangent beta is equals to beta, so beta now equals to OP upon P, which is our equation B. Since OP is equals to AB, which is height of the object, we have considered AB as the height of the object in the previous diagram. So now beta is equals to AB upon P, which is our equation C. Putting the values of beta and alpha in equation A, magnifying power is equals to AB upon P divided by AB upon D. Now AB and AB cancels with each other, so you will get magnifying power equals to D upon P, which is our equation D. Now here we will use thin lens formula, according to which 1 upon f is equals to 1 upon p plus 1 upon Q, such that P is equals to plus P, Q equals to minus D, because the final image is virtual, and F equals to positive F for convex lens. So 1 upon F is equals to 1 upon minus D plus 1 upon P. So 1 upon F is equals to minus 1 upon D plus 1 upon P. When you multiply both sides by D, you will get D upon F equals to minus D upon D plus D upon P, and D upon F is equals to minus 1 plus D upon P. Now 1 plus D upon F is equals to D upon P, or D upon P is equals to 1 plus D upon F, which is our equation E. Comparing equation E and D, we get magnifying power equals to 1 plus D upon F, which is our required equation for a simple convex lens behaving as a microscope.